Welcome back to another learning series with Mr. Knight. If this is the first time, welcome. Today we're going to explain quantum numbers, but before you start this lesson, I want you to have a notebook or a sheet of paper. Also, walk with some water so you can drink as you go along. Because I want you to be comfortable and watch this lesson all the way to the end. Now, to begin, quantum numbers, they are numbers that are used to describe the distribution and position of electrons in an atom. To understand this concept, the first thing I want you to think about is an atom with a positive nucleus. And surrounding that positive nucleus are some shells. On each shell, you'll have negatively charged electrons moving around, forming specific shape and also moving around in specific direction and orientation. Now, looking at the shell a little bit further, again, remember the shell, otherwise called the energy level, surrounds the positive nucleus. Within each shell, you have what they call subshells. And on subshells, you will have orbitals. Now, this concept will be very important for you to understand quantum numbers. In fact, it is very important for you to understand how electrons are distributed. So the first thing to always think about is the shell, and then the subshell, and then the orbitals. And so once you put it together like this, the quantum numbers will be way easier for you to understand. So let's go into now looking at the quantum numbers and their meanings. So the first quantum number, which is n, and it represents the principal quantum number, and this denotes the size of the orbital. The second quantum number is L, and this is the angular momentum quantum number. It is also called the azimuthal or the secondary quantum number, and this denotes the shape of the orbital. The third quantum number is ML, and ML represents the magnetic quantum number, and this denotes the orientation. The fourth quantum number is MS, and MS is the electron spin quantum number, and this regards to the spin of the electrons. Now let's look at the values for these quantum numbers. So we have n, and to remember that n represents the shell. So you think about n, you think about the shell. Remember the order. And then the numbers that are assigned to shells, remember, will be regular integers starting from 1, 2, 3, 4, and so on. Now the second quantum number, again, is L. And remember, what comes after shell will be our subshells. So L represents the subshells. The value that assigned to subshells will be based upon 0 to n minus 1. So if you notice so far, L must be lower than n at all times. The third, which is ML, and ML represents the orbitals. So first shell, subshells, then orbitals. The values that are assigned to ML is based upon L. And so this will be minus L to positive L. A point to note is that each subshell or L value will has its own values of ml, and you will see this when I go a little bit further. ms again represents the direction of the electrons, and ms has only two values, which are positive a half or negative a half. And so we're going to apply these values in a short while and see how applicable they are in terms of the structures of the atom. And so we're going to move from notes to the structures and make this relevant. Now let's look at an example. And this example states determining the possible L and ml values when n equals to 3. The first thing that you must think about is the organization of electrons. First, we think about shell, subshell, and then we think about our orbitals. So where n is equal to 3, here we know that this is the third shell. And so the L values, if you should remember, starts from 0 to n minus 1. So the values that can be assigned to L will include 0, 1, and 2. Now, for the ml values, remember it will be from minus L to positive L. So let's look at our first L value, which is 0. Now remember, there cannot be a positive or a negative 0. So 0 is just 0. So when L is 0, ml must be 0. Now, let's look at when L equals to 1. So we're going to move from negative 1 to positive 1. And so we're going to have negative 1, 0, and positive 1. And so the ml value when L is equal to 2 will start from negative 2 and stop at positive 2. So it'll be negative 2, negative 1, 0, positive 1, and positive 2. So notice each L value has its own set of ml values. All right, so now we understand that. We could go a little bit further now and talk about what these actually mean. And so n again represents the shell, and since it is 3, then it is the third shell. The values for L, there are 3 sets of value when n is equal to 3, which are 0, 1, and 2. So there are 3 values, which means that there are 3 subshells. Now look carefully on the ml sides, and the ml side represents the orbitals. And so there are 9 values in total, which means that there are 9 orbitals. And so let's look at these numbers to get this 9. First, we have 1 value, which is 0. Then 3 values, minus 1 to positive 1. And then we have 5 values. So altogether, we have 9 values for ml, which means that you have 9 orbitals. And so when n is equal to 3, we are referring to the third shell, and the third shell will have 3 subshells. And when there are 3 subshells, based upon n equal to 3, we will have 9 total orbitals. Alright, so this example is out of the way. Let's go into this a little bit deeper. And so what I wanted to look at this point or note, again, we're referring to this all the time: shell, subshells, orbitals. All our examples, when I apply this concept to it. This is where the fundamental concept begins. And so, to note this, reminding you that the shell refers to n. So wherever you see an n value, we are talking about the shell or the energy level. Whenever you see the subshell, we're talking about the L values. And when we talk about orbitals, we're talking about the ML values. Okay? So now let's go in a little bit deeper into the atom. And so we're going to look at the maximum number of electrons that can be on each shell. This equation is based upon Bohr's calculation. To determine the maximum number of electrons on each shell, it is given as 2n squared. And again, remember, n is the shell. And so if we're talking about the first shell, where n is equal to 1, then the maximum number of electrons is given as 2 times 1 square. 1 square is 1 times 2 is 2. So there are 2 maximum electrons on the first shell. For the second shell, where n is equal to 2, then what we have is 2 times 2 squared. 2 times 2 is 4, times 2 is 8. So there are maximum of 8 electrons can occupy the second shell. For the third shell, will be given as n equal to 3. So therefore, the maximum number of electrons will be 2 times 3 squared, which give us 18 maximum electrons on the third shell. Now for the fourth shell, you'll have n equal to 4, and so it will equals to 2 times 4 squared. 4 squared is 16. 16 times 2 is 32. So there are 32 maximum electrons on the fourth shell. And so the first shell holds a maximum of 2, the second 8, the third 18, and the fourth 32. And you can go ahead and practice for the fifth shell and 6 and 7. So you can just put different numbers for n and practice. Alright, so let's continue with this some more. Alright, and at this time I think you can pause and get a sip of your water that you have. Okay, and be relaxed and comfortable as we dive in some more. Alright, so now we're looking at the number of subshells per shell. And this one will be easy to remember. Okay, so once you establish the shells, you're pretty much good. And so let's look at the first shell. The first shell has 1 subshell. The second shell has 2 subshells. The third shell has 3 subshells. And the fourth shell has 4 subshells. Isn't this wonderful to remember that the number of shell or the number assigned to the shell is the same thing as the subshell? Easy to remember. First shell 1, second shell 2, third shell 3, fourth shell 4 subshells. Beautiful thing to remember. Alright, so let's get in it a little bit more and go a little bit further, because we really want to break this down and make it applicable to any possible question. Alright, so let's go a little bit further into this. Alright, the first subshell is assigned the letter S. So the first subshell is S. Alright, and so if it has 2 subshells, the first is S, then you have P. If you have 3, then going to be S, P, D. For the fourth shell, which has 4 subshells, again the first subshell is S, P, D, and then F. And so you need to remember that the first subshell is always S. And so you look at it like that: S, P, D, and F. After F, then you can assign regular alphabet, such as G, H, and so on. But for now, the fourth subshell will be our major concern, up to the fourth. Alright, so let's go a little bit further into this now to make this even more applicable and break it down some more to make it attached to the structures of atom. Alright, so let's look at now the subshell and the associated L values. Now we talk about SPDF, and so remember the first 4 subshells will be S, P, D, and F in that order. The first is always S, P, D, and F. Now it turns out to be that The S is assigned a value of 0. Okay, so you need to remember that. 0. I'm going to tell you why. Alright, that's something for you to remember why. And so P is assigned a value of 1. D assigned a value of 2. And F assigned a value of 3. And so that's a little thing to remember the values. We are going to look at the orientation of these orbitals. And so the S, you'll notice it has a spherical shape. And this is for another lesson that I'm going to look at the shapes and so on. And so the second one will be shaped as a dumbbell. The third, which is D. And then F will look like that. Now, easy way to remember these numbers that are very important here is simply to look at these values and the shape. So I'm looking at these shapes in terms of dumbbell, just a way for you to remember. And so there's no dumbbell shape in the S, and so we say 0. There's one pair of dumbbell shape, and so we give the value 1. For D, there are 2 pairs of dumbbell shape, and so give a value of 2. In the F, there are 3 pairs of dumbbell shape, and so we give a value of 3. And so that's just a way to remember it. Again, when I go into the other lesson with this, I'm going to talk about the name given to S, which is sharp, P for principal, D for diffused, and F for fundamental. But we talk about that at another time. What we want to do is to understand these numbers and know how to apply them. All right, so let's jump in some more and looking at the subshell with the associated maximum number of electrons. So once we talk about S subshell, we're talking about certain value. We have P, we have D, and we also have F. So let's look at the values now. And so the S will contain a maximum of 2 electrons. P, 6. D will be 10. And F will be 14. And so what I want you to notice is that these values, they increase by 4. Okay? They increase by 4 as they go along. Alright, and so now let's think about an example. Let's say you're given this structure and it is mentioned that this is the 4th shell, or n equal to 4. So how many subshells do we have and how many orbitals? Very important for us to understand this. And so on the 4th shell, remember there'll be 4 subshells. 4 shell, 4 subshells. Always need to remember that. First shell, only 1. Second shell, 2. Third shell, 3. The 4th shell, 4. And so we'll have our S, our P, our D, and our F. Okay, so on the 4th shell, there are 4 subshells, S, P, D, and F. And now to associate the number of orbitals to these, when it is S, there's only 1 orbital. Okay? And when there is P, there are 3 orbitals. I'm going to tell you why shortly. And when there is D, there are 5 orbitals. And when it is F, there are 7 orbitals. And so to make mention of this, remember the number of electrons I showed you earlier. S can hold 2 maximum, P 6, D 10, and F 14. And so it turns out to be that each orbital, each of these boxes represent a single orbital. Each single orbital can only hold a maximum of 2 electrons. So if S has 2 electrons, only 1 orbital is needed. Okay? And of course, we can calculate this number. I'm going to show you how to calculate the number of orbitals. Okay? So first, here we'll have 2 electrons for S, 6 electrons for P, 10 electrons for D, and 14 electrons for F. Now let's break this down. Again, remember, each orbital can only hold a maximum of 2 electrons. And so to put electrons in this, first you go upwards, then downwards. You go to the P, go upwards all the way across, then you start with the down going all the way across. And so you do the same for D as well, all the way across up, and then you start with down going across. Alright, until you have the maximum number of electrons. For the F, the same thing, you go all the way up, all the way across, and then you start with the down going across as well. Now, to know the number of orbitals, remember the calculation that we need to remember is simple. This is that if we think about it, we think about S as a L value of 0. And so if the L value is 0, the ML values, and remember orbital refers to the ML value. So let's go again. The shell is for N, the subshell deals with L, and then the orbital deal with the ML values, okay? And so to remember, if there's 0 for L, then our ML values will be 0 as well, because there's no negative or positive 0. And so for P, again, remember the L value for that will be 1. And so we can have a negative 1, we can have 0 and 1. So there are 3 orbitals for the P subshell. And for the D subshell, remember the L value for that will be 2. And so we could have a negative 2, a negative 1, 0, 1, and 2. So those are the L values. And notice the total values right here will be 5. And so there are 5 orbitals for the D subshell. Now to break down the F, again, remember the F has a L value of 3. And so we could have a negative 3, negative 2, negative 1, 0, 1, 2, and 3. And so this will give us our 7 orbitals. Alright? And so if you add up all the orbitals for n equal to 4, you get all these numbers together. Okay, so that's an easy way to remember it, to break down the subshells first, and then you look at the number of orbitals. Alright, so once you understand this, you could pause this, look at it, look how it worked out, look at the n value, then the L, and then the ML value. Okay? Alright, because remember, from n is equal to 4, the L value must be from 0 to n minus 1. And if it is 4, then the highest number has to be 3. Alright? So beautiful. Alright, so the next thing I want to look at now is all of this together in distribution in terms of this chart. And so we're going to look at the shell, the subshell, the number of orbitals that are there, the maximum number of electrons, and the total number of electrons. And this is just a summary of all that we have been doing so far. So let's start with the first shell, which is n equal to 1. It has only one subshell, and the first subshell is always S. And so the number of orbitals for this can only be 1. And the maximum number of electrons on a single orbital is 2. And so on the first shell, there is a total of 2 electrons. Now for the second shell, remember, if you have 2 shells, for the second shell, there will be 2 subshells. And so you'll have a 2s, and remember the 2 just denotes which shell are you talking about, okay? So the 2 before the s is telling what shell it's on. And so the subshell for that will be 2s and 2p. The second shell, 2 subshells. Just remember that, okay? And then the number of orbitals for the s will be 1. S is always 1 orbital. And p will be 3. And the easy way to remember it is that you look at the number of electrons. S has 2 electrons, so just divide it by 2, you get 1. P has 6 electrons, so divide it by 2, you get 3. That's the next way to get the number of orbitals as well. Look at the number of electrons that can hold on that subshell. Alright, and so for 1, if it's S and 1 orbital, you'll have 2 maximum electrons. If you have 3 orbitals, remember, you multiply by 2 here, you get 6, okay? because each orbital can contain 6 electrons. And so on the second shell, a maximum of 8 electrons can hold on that one. And so if you go to the third shell, now we're going to break down the third shell, and you can go ahead and think about this. Third shell, 3 subshells, and so it'll be S, P, D. And therefore now, the S again, 1 orbital, the P, 3 orbitals, and the D contains 10 electrons, and so divided by 2, they're going to get 5. Okay? And so there are 5 orbitals there. And so again, for the S, you can only have 2 maximum electrons. If there are 3 orbitals, then you multiply by 2, you get 6 electrons. If there are 5 orbitals, then you multiply by 2, you get a maximum of 10 electrons. And so the total number of electrons on the third shell will be 18. Now let's look at the fourth shell. The fourth shell means that you have 4 subshells. And so you'll have your 4s, your 4p, your 4d, and what comes next, if you remember, is f. And so we have our 4f. Again, the numbers before the letter is just specifying the shell that these subshells are on. Now the number of orbitals again, for s is always 1 orbital, p 3, d will be 5, and if f contains 14 electrons, then the possible number of orbitals will be, half of that will be 7. And so we have 2 electrons on the 4s, 6 electrons on the 4p, 10 electrons on the 4d, and 14 electrons on the 4f, or the 7 orbitals in total. And so the total number of electrons here will be 32. And so this is a breakdown from the first shell up to the fourth shell in terms of the subshells, orbitals, number of electrons maximum, and the total number of electrons on that shell. And remember, what I want to remember is always the subshells always start from S, P, D, and F, and so on. The number of orbitals is half the number of electrons that can hold on that subshell. Alright, so let's go a little bit further into this, looking at now a learning check, and then look at some examples shortly, and then we'll finish. Alright, so if you're given this quantum number 3p5, what this is actually telling you, do you understand what this means? Again, the first number always refers to the shell or n. So we know that this is dealing with the third shell. Okay? And on the third shell, if it's P, remember now you could have 3 subshells. You could have either S, P, or D. But at this example, we're looking at P. So they give us P. And so P, which is a subshell, and remember that will be, the first is S, then P. So this is the second subshell, okay? And then we have our number of electrons. P can hold a maximum of 6, but in this example, there are only 5 electrons. And so let's put it together. If we have 5 electrons, just organize them to see how they look. So this is a P, and there are 3 orbitals, and so therefore it could be a total of 6, but for this we only have 5. And so remember, we could have a -1, 0, +1. And so to fill this, first we have to go up, up, across, and then we can start with down, down. We do not have all 6 electrons, so we'll stop at that point. Okay? And so it will look like this. That's how the orientation of electrons will appear. Alright, so now that's good. Now look at this one here. It said, what are the possible quantum numbers for the 5f orbital? So looking at the possible quantum numbers just for 5f. And remember, if you see 5f, there's something that should come to your mind, is that n equals to 5. Okay? That first thing is 5. And then if it is f, remember it is S, P, D, and F. S starts at 0. So let's think about the L values now. Because remember the values, starting from the shell is N, the subshell will be L, and the orbital will be ml. So let's figure out the L value. Remember, the first subshell should be S. It is not S we're dealing with, so that will not work. It only starts with 0. And then we have our second, which is P. And so P is 1. And if P is 1 and we're not dealing with P, and then we can look at our third, which is D, and that is dealing with 2. We're not dealing with that. So the one that comes after D is F. So if F is equal to 3, then our L value must also be what? 3. Okay, so that's how you get your values for L. Remember, S, P, D, and F. S always starts with 0, then 1, then 2, then 3. Right. So now you understand that. Now, if L is equal to 3, then what will be our ML values? And our ML values will start from negative L to positive L. And so our ML values will be -3, -2, 0, +1, +2, and +3. So these are the possible quantum numbers for the 5f orbital. All right, and so I hope this is a little bit more clear for you and easier for you. All right, so now let's look at this one, and we're now going to describe the electrons that are represented by the following quantum numbers. So if you're given n equal to 2, while L is equal to 1 and ML is equal to 0, now the first thing you need to look at is the n value. And if n is equal to 2, then we know that the first number has to be 2. Then if L is equal to 1, and that's the next thing you look at, where L is equal to 1, and remember the L value associated with the subshell, S, P, D, and F. S is 0, so the 1 must go for what? P. Okay, so when L is equal to 1, then it is P. Now our ML value, which is 0, is not necessary to put a number because that do not tell you the electron or the number of electrons. What we can assume now is that in the middle of the ML value, where 0 is always the middle number, the last electron will be right there. Okay, and thus we can look at that and know exactly where it is. Now for B, now the first thing I get to look at is our n value, which is 2. But there's something that's stored out right here. L is also equal to 2. Now remember, L must always be lower than N. And so if L is the same value or higher, then you know that this quantum number is not correct. It is not possible. All right, and say this is not allowed because simply the L value must be lower than that of the N value. To prove this, remember that L is equal to 0 to N minus 1. So it must be at least 1 less all the time. All right, and so now we're at the end of the lesson. I know it's a little bit lengthy and we spent a good time. I have fun with you today, and really I'm looking forward to see you in other lesson. So I'm looking forward to see you when I post the other lesson and on quantum numbers. So in the meantime, stay safe and come back again.